I'm good.
Alrighty.
Okay, so got number 1 and 2.
Yep.
And then, sorry, let me scroll up. I just the bottom. ANOVA hypothesis test. We reject the null when there is sufficient evidence to indicate at least one mean is different from the others. True.
Yeah. 4. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
Data in each group are normal and the variances are equal.
Yep.
To check if each group is normally distributed, do the following. Oh, I hate this. Construct a QQ plot for each group.
Yes. So how do you do that? Is there like...
It's a pain.
Yeah.
I went through I went through and like did the whole quiz and just saved it. And it took a while because I think here in just a sec we're getting into a couple. Yeah. Well, yeah, not quite yet, but we're getting to. There's like some shoe.
Yeah. Yeah. Well, I did the whole quiz as well and saved it. Same thing. But that's the thing. I just like got on some QQ plot that I found. I just looked it up on the internet. I have no idea what to do.
I looked at a video on YouTube because I couldn't figure it out from any of the reading.
Yeah.
And you have to have like 4 columns in Excel. You have the all the values in one column, and then you sort them in order from smallest to biggest. And then you have your next column, which they on the video called the I column, but it basically just counts 1, 2, 3, 4, 5, 6 up to the how many values there are. So if the soccer shoes, there's 20 values. And then the next column over is I minus 0.5 divided by the population of the sample. So that one was 20. And then you go down the column doing that. Then there's 2 other formulas for the next 2 columns. And then you have to make a scatter plot at the end of that.
Fun.
Yeah.
All right. Well, we'll deal with that when we get there.
Okay, number 7. An ANOVA hypothesis test. Oh, wait, no, not that one. 6. We assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest variance.
4. Yeah.
Okay.
All right. 7. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there in a 4-sample? I put 6.
Yeah, that's what I got to. Number 8. What's the minimum variance for the 6 groups? I got 27.208.
Same.
Okay. And the maximum?
53.158.
Same.
Cool.
The test for equal variances is satisfied for this data.
True.
True. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. I got true on that.
Okay, yeah, I didn't. Anything with the QQ plot, I didn't know what to do. So I was like, so the first column is the data, right? On the QQ plot.
Mm-hmm. I'm going to screen share.
Huh?
Hold on. Let me see if I can. Oh. Yeah. Okay. So I'm on YouTube. Oh. Right there. I think this. Can you see my screen?
Yeah, I can.
Okay. So here it is. Can you still see it? You're good?
Yeah.
Okay. So this is what it looks like. And so you have this group, which is the values. And then And I don't know if it makes any difference or not. I guess it does if you're looking for variances. But in the video I watched, it said to sort them from smallest to biggest, and then there's I, which you just do 1, 2, and then drag it.
Yep.
And this one is the same thing. You just do this, where you do the I minus 0.5 divided by 20, and then you drag that formula down.
So then, I minus 0.5 divided by 20?
Yeah. So this one's like the 1 minus, 2 minus, 3 minus.
Yeah.
And then this column is start typing in norm, and then it puts, this is one of the options, the norm S inverted. And then from that you type in this column right here is the percentile, is what I understood. So you type in that, and this column means the theory of Z, like that's the Z theory column.
Uh-huh.
And then this is the actual Z score. So then you just put in the formula for which is value minus average of that column. But you have to make sure that you put in the anchors right here and here to make sure that it's always going to be from this to this, because that's going to be the average every time. Same with standard deviation. You always have to put in those dollar signs in between the number and letter to secure that, like just to make sure that's the anchor. So then after you get those two columns of the actual and theory, the theory Z-scores, then you highlight both columns and then go to insert and do a chart here. And then you just do this scatter plot and it tells you, which ignore that just popped up. But so these are I'll show you the scatter plots that I got from doing these QQ plots. And you tell me if any of them look not so normal. I think they're all pretty normal.
Yeah. See, because I was always confused at what point is it no longer, because I know like it's supposed to be along the line, but I don't know if there's if anything.
Yeah.
If there's like gaps and like, because even with pretty good, like mostly on the line, I've seen like examples in the book that it seemed like it's not, but like those all look pretty good.
Yeah, and they come out just as the scatter, and you right click it, and then you add a trend line, and then you decide which one. Oh, I didn't mean to actually do that. Dang it. I don't know what I just did. Oh well.
Gotcha.
But yeah, I think that these are all pretty linear, normal plots.
Yeah, sounds good.
Let me stop showing that because it's okay.
All right.
Help?
Yeah, that helped for sure. Thanks.
So then perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data. Can you hear me okay?
Yeah.
Take out the SOX data and perform the test again. What's the p-value when we remove the SOX data? Did you have that?
Yeah, yep, 0.309.
Same. Okay, this one I wasn't sure. The test statistic for ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left? I put the right.
I put right as well because I thought I was talking about the graph.
Yeah, and it says something about that in the reading, which I don't know if that was like consistent or if that was a one-time thing, but
yeah, I think it's right. If not, we'll put left.
Okay. And that's as far as I got. I wasn't able to finish, but we can keep going. Researchers at Consumer Reports analyzed 3 types of hot dogs for each. Okay, so they recorded the data. That's the data. Examine the calories first and construct QQ plots for each of the calories. for each of
So yeah, because I can't do the QQ plots. It's got to be one of two answers.
Okay.
And so, yeah, it's either that it's right and the QQ plot works, or if it doesn't work, that means that it's not normally distributed because the variances are good.
Okay. Let me see really quick. Are you trying to do it too, or are you just waiting for me?
Yeah, I figured QQ plots are just going to take me a while, so I'll figure, well, I'll like do it later on.
You want me to put it on screen share so you can watch?
Well,
I'm...
or what YouTube video did you watch? Do you know which? Because that may
I
be easier.
I'll find it again and I'll text it to you.
All right, that works. Have you done the review one yet?
No, I haven't.
Gotcha. So I've got till about 6-ish before.
Okay, that's okay. We don't need to do that one today.
Sounds good.
Because yeah, you can wait till Thursday to do the review. Sorry.
Oh, no worries.
Okay. This first one isn't normal.
Okay. So then it would be
Assumptions have not been met, right?
yeah, so it'll be the third option because you can assume that it's normally distributed, but we can assume that the variances are equal.
Okay. Okay.
15. Running the test to determine if the average number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51, that the F is 16.074, and that P is 0.000 with a level of significance equal to 0.05. What conclusion can you draw? And I put we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type. Because the p-value is less.
Lots of QQ plots. Okay.
Well, this one, fortunately, we don't really have to make it. It just tells us.
For the next one?
Yeah, in the exam. So, I'll read.
So never mind. Okay, you should see.
Yeah, so it already tells us that one of the QQ plots isn't normal. So it'll be the same answer that we got for the other one.
Okay. What's the p-value for this test?
At 0.179.
Okay.
Then 18. What conclusion can you draw from the mean sodium levels of the three types of hot dogs? Use significance, level of significance, 0.05. Then I say that we don't have sufficient evidence to reject the claim that all three hot dog types have the same mean sodium levels.
Okay.
Do you agree with that?
Yeah.
Alrighty, that's the moment of truth. We only missed one.
Okay. Which one is that?
It was the calorie QQ plot for the hot dogs. So, which means
no, number
14.
14?
Yep. So that means that the assumptions were met.
Wait. No, they weren't met though. So why can't it be option 2 or option 4?
Because the does not say. Because the variances are equal. And so like the fourth option, it says that the variances we cannot assume the variances are equal, and then the second one it says we cannot assume the variances are equal.
Okay. Well, because it wasn't normal.
Yeah, so I don't know what.
So I would keep it as the assumptions have not been met for one of them. Let's see. Okay. And you had put that it's not normal.
That the assumptions weren't met because
the variances are equal.
That variances are, but the distribution wasn't
normal. Okay.
Fortunately, that's the only one we missed, so it's still good either way.
Hold on. Just a sec.
Yeah, we can probably take, take those empty bags down, but this stuff, so, I'm gonna need this stuff. And close the door. Now, how did you like recording that?
Yeah, I'm still on it.
Did you figure out what it was, or?
Not yet, just because when I left my apartment, anyway, it like hadn't connected to the internet here as far as with the quiz. So I just had to write down what answers I had and
Oh, gotcha.
fill in the last like 5 answers is all. Now that I'm here.
So all this stuff on the ground can go, except for the empty bags there. That's upstairs.
Can I put your shoes in your laundry basket?
I'll give you permission. Yes, you can.
Back here. No, that's good. Okay, great. That goes in that bag. Oh,
Okay. Well, now I'm submitting it. Wait, I missed 2.
What numbers did you miss?
Number 14, which I put a different answer, so it's not the last answer. Oh, that's why. Anyway, it's right, but I marked it left. I missed number 13
Oh, gotcha.
when I changed it, and I didn't look to change it. So you know it's not the last 2. So you're
Yeah.
positive that the variances are equal?
I'm almost sure. I think I am. I'll just go ahead and put it and submit it. And that way, if it is wrong, you'll get it right.
Because I may have done the math wrong on the QQ plot.
Yeah, it is correct.
So it's that it's normal and the variances are equal?
Yep.
Dang it. I don't know that I would call that a normal distribution, but okay.
Yeah.
We're good. I'll just fill this out and you can go.
Sounds good. And so on Thursday, I'm open like pretty much all day Thursday up until about 6-ish, 7-ish.
Okay. I get off work at 5 o'clock, but I'm out of class at 9:30, and that's my only class that I have that day. And then I don't go in to work until noon. So anytime between that time.
Want to go for just like 10 o'clock in the morning?
Yeah.
And try and
let's maybe shoot for 10:30 or 11, just because. Does that work for you, or?
I've got an 11:30 class is the only.
Never mind. We can shoot for 10.
All right. Just whenever. I already did the review, because on lesson 15 it says that the review is just the whole thing. It says review questions, and so I just went through and did it, and so that shouldn't be too bad. I only had a couple questions.
Okay. I have to move out tomorrow, so life is just kind of hectic.
Gotcha.
So.
All right. Sounds good. Well, let's plan on then. If things change, just let me know.
Okay. Sounds good. Okay.
All right. Bye.
See you Thursday. Okay. Bye.